Hey, what's up everybody? It's Paul the Solar Guy coming at you with another video on site with the dual axis tracking system. What we're going to be doing today is we're going to be swapping out an optimizer. It's actually going to be on this panel right there. So of course, as you can see, it's up at the highest position right now. Again, since it's a tracking system, the pitch of the array is going to match the time of the year. So right now it's January 6th, something like that. So the sun's really low in the sky. So the array is going to be really perpendicular to that sun angle. And in the summertime, as the sun's higher in the sky, the array will actually tilt back and become a little bit more flatter. Again, to try and capture as much direct sunlight as possible. So the pitch is the time of the year, and the angle side to side is the time of the day. So as we can see here, it's aiming kind of left as you're looking at it from the array's perspective. And as it goes across the day, it'll track towards the right, but the fixed angle will stay the same for today. If we sit here for a few minutes, you'll actually hear it kick on every few minutes or so. It'll actually move over to keep tracking the sun. It doesn't always move to try and restrict the usage on the mechanical components of the system, but like I said, every few minutes it'll update its GPS position data and move the array accordingly. So first thing what we're going to do is whenever we show up on site is we shut down the system. First thing, before we do anything else, if we're going to be servicing the system, shut it off. So that's the solar system. The array tracking motor, what that does is if it loses power, once it regains power, it'll go into its standby position, which will be perfectly flat, and then it will start gathering its GPS data again. And that usually takes like 5 minutes or so. So what I'm going to do is I'm going to shut down the whole system. I'm going to turn the motor back on, wait till it gets into its standby position so it's perfectly flat, and then I'm going to shut it off again so that it stays in that position. That way it's perfectly flat, getting the optimizer down a little bit lower, making it easier to facilitate the replacement. So basically what we're going to be doing here is, this is a Solar Edge optimizer. So this connects to the input of the module, and then it gets connected to all of the other optimizers in what we call a string. So all of these optimizers together connected, I think this array is what, 12? Yeah, so 12 per string. So there's going to be 12 of these optimizers hooked together in 2 sets of 12, so 2 strings of 12, if you will. Each optimizer has its own PV module. This is basically, it's technically a DC to DC converter, basically like a little transformer, so that this can control the output power of each individual module. So what that does is it facilitates rapid shutdown requirements. So if you shut down the inverter sends a signal to all of these guys. These guys will physically open up inside and disconnect the electrical connection from their module to the inverter. So that will actually shut down all of the power leaving each one of these individual optimizers, and it limits the array voltage to whatever the panel voltage is coming into this optimizer. So essentially it's roughly right around 60, 70, sometimes maybe even 50 volts. So in a rapid shutdown situation, everything is limited to 50 to 90 volts underneath each module, and then anything leaving the array is completely safe. Again, not a requirement for this ground mount system since it is a standalone ground array. The rapid shutdown requirements really more apply to buildings where they would be occupied by people, and if there was an emergency, firefighters had to perform some life-saving procedures. They know that it's safe. They can knock down whatever walls they need to once they kill all the power, and without risking injury to themselves. So the rapid shutdown basically allows them to put an axe through any of these pipes and any of these wires, if they're in a pipe, and any of these wires as well, because the voltage is at a safe limit for them. So rapid shutdown requirements is all really about firefighter safety, so that they are safe performing the procedures that they need to do to save other people in the event of an emergency. The other benefit of an optimizer, they call them, again, they're DC to DC converters, but the industry likes to label the term optimizer because they do actually increase the output of the array, because if there's shade on this module or this module or this module or this module, or for some reason one panel stops working, again, since all of the optimizers are connected, all of the optimizers will still be working. Or if one optimizer fails, it has bypass diodes through each one. So if one optimizer fails, in the instance of this guy right there, the other 11 in the string still work. So you kind of get the benefits of a microinverter system, but not all of the electronics are up at the panel. You know, you just have half the electronics at the panel and the other half is at the inverter, typically down at a ground mount level or indoors would be the best location, away from environmental hazards and conditions. But again, this one being a ground mount, it's outdoors. Essentially, it's the same technology. You're getting a little bit more efficient system by equipping these optimizers, even if it's not required for rapid shutdown. Again, you still get those same features with a microinverter system. It's just these components underneath the modules are slightly larger because they contain more electronics. And we'll get into that in a different video. But this, like I said, pretty much just on the DC optimizer system. So again, what I'm going to go ahead and do right now is, first thing we're going to do is going to shut off the solar. Then we're going to shut off the array tracker. Let that get to its standby position. Shut it off, turn it on, let it get to its standby position, and then shut it off again. So I'm going to go ahead and do that, and you can watch this thing move. So perfect, now everything's all nice and accessible right from underneath it. We can access everything. You can see perhaps right now there's guards right here. I'll try and get a little bit better video of those up close. So those are required for a DC system because when it's running, these could be accessible. You know, somebody could come up with a ladder, start playing around with it. So we do have to protect people from themselves sometimes. So all of these DC components have to be guarded so that nobody can just walk up to them, cut them, risk damaging them, hurting themselves or damaging the system. So another way we know that it is that optimizer, because again, there's 24 of them up there, is each optimizer is assigned a serial number. So that serial number is tracked using the manufacturer's monitoring system. Hopefully when the installer, which again, we didn't install this system, but when the installer installs the system, they create a virtual map. And so they map out exactly where each serial number is on the array. So that way, in instances like this, if there's a device failure, we know exactly where it is. So we know how to replace it, where to replace it, what it is, everything like that. So basically that's how we're able to get the RMA procedure for this one, know exactly where it is, and get it swapped out and get this customer back up to 100% again. So that's what we're looking for. We try and make as much solar power as possible out here. So All right, so now it's finished waking up, but it's going through the pairing process. So now we just gotta wait for everything to match up, line up, make sure that there is in fact 24 different optimizers reporting to the one inverter. Make sure that the inverter has access to the internet and to the SolarEdge monitoring platform, and then we'll be all set. Just gonna tidy up a few things, put some covers on, and all done and ready to go.